Okay, so in this video, we're going to be talking about how to find the antiderivative, and in particular, when we're using the power rule. So the rule is pretty straightforward. Notice here that you're simply just adding 1 to the exponent, and then that goes down to your denominator as well. You do have this constant c here, so this variable c. That is representing our constant of integration, and we will talk about that. And then you have n cannot be equal to -1, because if n is equal to -1, then you'll have division by 0, and then the whole thing becomes undefined. All right, so we're going to show you how we're going to apply this rule in the following examples. It is pretty straightforward. So let's go ahead and take a look at our first example here. Okay, so before we start our actual examples here, we have to talk about this constant of integration, and we also have to talk about a couple of other key concepts before we can get into these examples. And so first, let's talk about taking the antiderivative of a function. All right, so for example, if you have f of x, and I want to take the antiderivative of f of x, I'm going to show that the following way. I'm going to say capital F of x. That means you're going to be taking the antiderivative of f of x. Now, if you're on this video, you've probably already taken the derivative. And so you know that when you take the derivative, you show that the following way. If you have f of x and you want to take the derivative, you would say f prime of x, okay? So this right here is how we're going to be taking the antiderivative and how we're going to be showing it. So capital F of x, okay? So again, that is telling you that you are trying to take the antiderivative here, all right? And also, remember, if I were to take the derivative of a function, so if I were to do f of x, and I take the derivative and I get f prime of x, if I then take the antiderivative, I'm going to return the original. So from this point here, if I take the antiderivative, I'm going to return the original, okay? And so essentially the antiderivative is the opposite of taking the derivative, right? Or in other words, it undoes it. So I want to look at this example here, this constant of integration c. That way you have a better understanding of where that variable is coming from when you take the antiderivative. So let's go ahead and get rid of all this here. And I'm going to give you a basic function here, and you can already see it. It says f of x is equal to 2x squared plus 1. So what I'm telling you to do here is the following. I want you to take this function f of x, and I want you to take the derivative of it, d dx. So if we take the derivative of f of x, what do we get? Well, again, we just have to apply the power rule here. And if we take the derivative, we get 4x, okay? And again, your 1, your constant, drops out. Again, those are your rules when taking derivatives. Now, if I want you to take the antiderivative now of f prime, that's what this is right here. This is f prime of x, right? That is the derivative of f of x. If I wanted you to take the antiderivative of f prime of x, you should return your original right here, okay? So in other words, how you would write that, you would say f of x is equal to the indefinite integral, and we're going to talk about that in a second, the indefinite integral and the definite integral. But right now, we're going to call this the indefinite integral of f prime of x and then dx. And so essentially what you're going to do, you're going to replace your f prime of x with what it is. That's going to be 4x. And then you're going to go ahead and take the antiderivative. And that is what you're seeing right here. Okay. So this 4x, I just replaced it where you see f prime of x, right? I replaced it with what it actually is. So before I show you what happens here, the indefinite integral just means that there's no limits. So for example, I do not have a limit on this integral here. When you're doing the definite integral, you will have a limit. Like you'll have a limit going from, let's say, a to b. And when you do the definite integral, you're going to return a value. Like you'll return like 20 or 50 or like 100. But when you're doing the indefinite integral, you're not going to return a value, you're going to return a function. Okay? So that's important to understand. We are dealing with the indefinite integral in this video here, meaning we're not going to be returning a value, we're going to be returning a function. Again, the indefinite integral does not have limits, whereas the definite integral has a set of limits going from a to b. And again, a to b could be anything. So going back to what we're talking about, if I take the antiderivative right here, I should get my original f of x. So let's go ahead and do that. Let me go ahead and get rid of all this here. And we're going to apply the power rule. Now remember, this really has an exponent of 1. So I'm going to add 1, and then whatever I get for a value there, I'm going to put on my denominator. And so I'm going to say equal to, and applying the power rule here, we're going to add 1 and then divide by that number. So we get 4x squared all over 2, which ends up being 2x squared. So this should be equal to my original f of x. And if I look at it, well, I only have the 2x squared. I'm missing my constant, okay? So this is why you always need to add a constant, or in other words, plus c at the end when you take the antiderivative, some constant c. Again, we call that the constant of integration, so plus c, all right? Because again, remember, when you take the derivative, you're essentially dropping that out. And so when I go in reverse and take the antiderivative, there's no way of knowing what constant you had there. So we're just going to represent that with c. All right, so this would be done right here. Okay. And so also it's important to understand here that if you're doing the indefinite integral, meaning you have no limits here, you're going to be adding c. However, if you're taking the definite integral and you have a set of limits, let's say going from a to b, you are not going to be adding c. Okay, so that's kind of a key difference there. When you're doing the indefinite integral, you have to add c. When you're doing the definite integral, like we have here, you do not need to add c. All right, but again, we're going to be dealing with this one right here today. That is going to be the indefinite integral. So let's go ahead and take a look at our examples. Okay, so let's try our examples here. And you can see that I'm taking the indefinite integral of 4x and then dx, meaning in respect to x. So again, I'm going to add 1 on my exponent. That will give me 2 because there's already a 1 there. And then I put that on the denominator. So I say 4x squared all over 2, and that will give me 2x squared. But remember, you always have to include the constant of integration, so plus c. And this will reduce down to 2x squared plus c. And then we're done, right? So there's that one. Okay, let's go ahead and try another one. This one here is in respect to z. That's why we have dz, right? So I'm going to, again, add 1 here and then put that number on the denominator. You get 2z to the third power all over 3. Add the constant of integration, so plus c, and there you go. You're done, right? Nothing else I can do there. This one here is in respect to y. Now you're going to do this in parts. You're going to do this part here and then this part, and then at the very end, add your constant of integration. So I'm going to say here 2y to the third power all over 3. And then again, you do have an exponent of 1 here. So plus y squared all over 2, or you could say a half y squared, right? That is going to be the same thing. And then again, don't forget about your constant of integration. So plus c, and then we're done. All right, let's go ahead and try this last problem. This one here is in respect to a, so dA. So again, I'm going to add 1 and then put that on the denominator. I get 4a to the 4th power all over 4. And then we have plus our constant of integration. And we can go ahead and simplify this down. The 4's will cancel here. So I get a to the 4th power and then plus c. And then we're done. Okay. So those were pretty straightforward. All right, let's go ahead and try some more that are a little more challenging. So here's my next example, and they give me the function f of x, and they want me to find what is capital F of x, meaning they want me to find the antiderivative here, because again, if they give you that capital, right, you know that we're dealing with the antiderivative here. So let's go ahead and write this out. We're going to say capital F of x is going to be equal to the indefinite integral. So I'm going to say the indefinite integral of f of x and then dx, right, in respect to x. So what do I end up getting here? Well, let's go ahead and replace f of x with what it is. So I'm going to say here equal to the indefinite integral of, and then I get x to the 3rd power plus 2x squared plus 2, and then again dx. And then we can go for it. So again, you're going to do this in parts. I'm going to do this part, this part, this part, and then at the very end, add your constant of integration. So I'm going to go ahead and say here equal to, I'm going to add 1 and then put that on the denominator. You get x to the 4th power all over 4. This one here, we're going to add 1, we get 3. So plus, we get 2/3 here, or you could say 2x to the 3rd power all over 3. That would be fine, right? And then plus, now be careful here. How am I going to do this one? Technically, that constant has a variable of x to the 0 power. So for example, that 2 is really x to the 0 power. And so if you add 1 and then put that on the denominator, what happens? Well, I add 1 and then all over 1. Well, that's going to give you 2x, right? So when you're dealing with a constant, you just go ahead and put the variable on the end. That will always work out. So I'm going to go ahead and say here, 2x. And then don't forget about your constant of integration, so plus c, and then we're done. All right, so capital F of x is equal to the following. And there we go. All right. Okay, let's try another example. Okay, so here's our next example. In this one here, we're given the derivative of f of x. I have f prime of x, and they want me to find f of x, meaning they want me to find the original here. And so think about it. We know that when I do the antiderivative, that is simply the derivative in reverse. So if I took the derivative of the original and I got this here, if I want to find the original, I'll have to take the antiderivative of f prime of x, and that will give me f of x. So I'm going to say the following. I'm going to say f of x is equal to the indefinite integral of f prime of x and then dx. And then going ahead and doing the substitution here, I'm going to say equal to the indefinite integral of f prime of x is 2x squared, and then plus 5x, and then plus 2, and then dx. All right, and then we're going to go for it. So again, applying our power rule here, we're going to add 1 and then put that on the denominator. So for my first term here, I'm going to get 2x to the third power all over 3. And then plus, this will give me 5x squared all over 2. And then I have plus 2x, because again, I'm dealing with a constant. We know that we just add the variable on the end when that occurs. And then don't forget about your constant of integration. So plus c. Again, some constant c. That is going to be f of x. So f of x is equal to the following. Okay? All right, let's go ahead and try 2 more examples. Okay, so here's my next example, and this is definitely more challenging than the other examples we've done. So they're giving you the derivative of f of x. I can see that right here. I have f prime of x, okay? They want me to find the antiderivative of capital F of x. So in other words, in order to do this problem, you first must know what f of x is, the original. Once you know f of x, then you can find capital F of x. So to kind of show you the progression that we need to do here, I need to go from f prime of x to f of x, and then from f of x, I have to do capital F of x. And that is how we're going to do this problem. So you actually have to take the antiderivative 2 times. One time going from f prime of x to f of x, and then going from f of x to capital F of x, right? Our antiderivative of f of x, right? So let's go ahead and do this problem. Let's go ahead and get rid of all this here. So my first step, I have to find f of x. So I'm going to say here, f of x is equal to the indefinite integral of f prime of x. So f prime of x and then dx, which will be equal to the indefinite integral. Now we'll go ahead and substitute in. F prime of x is going to be 3x squared plus x plus 1 and then dx. And then we can go ahead and apply our power rule here. We're going to get the following. F of x is equal to, so adding 1 and then putting that on the denominator, you get 3x to the third power all over 3. And we'll take care of simplifying it down at the end. Like those 3's will cancel out, but we'll wait till the end to do that. And then we have plus x squared all over 2. Okay. And then we have plus x, right? Because I have a 1 here. That's my constant. So technically it's 1x or x. And then don't forget about your constant of integration. So plus c. Okay. So I know that the 3's will cancel here. So I'm left with x cubed. And there we go. So now I have to take the antiderivative of f of x. So going a little bit further, I'm going to say capital F of x will be equal to the indefinite integral of f of x, what we just found, dx. And so now we're going to go ahead and rewrite it. the indefinite integral of, substituting in, we get x to the third power plus 1/2 x squared. So again, I'm just rewriting that term as a fraction out in front rather than write it as x squared over 2. It's going to be easier to go ahead and put that coefficient out in front when we do the power rule, okay? And then I'm going to say plus x and then plus c, right? So let's go ahead and do this. Now I'm going to scroll down a little bit, that way I have room. And let's go ahead and go for it. So capital F of x is going to be equal to, applying the power rule here, I have to add 1 and then divide by that number. So 3 plus 1 is 4, and then dividing by that number, I get x to the 4th power all over 4. Going on to my next term here, I have to add 1 and then put that on the denominator. So I get plus 1/2 and then x to the 3rd power all over 3, which is really 1/3. So what you're essentially doing here is 1/2 times 1/3. So that's going to give me 1 over 6. So I'm going to go ahead and rewrite this one as 1 over 6 and then x to the 3rd power, okay? So rewriting this one, I'm going to get 1 over 6 and then x to the 3rd power. And then this one right here, I'll get plus x to the 2nd power over 2, or you could rewrite it as 1/2 x squared, right? And then my constant, again, I have to do this in respect to x. So if I have some constant here, I'm going to say plus cx, right? But remember, I just took the antiderivative again, meaning I have to include my constant of integration. So we're going to go ahead and use another variable now. We'll just use d. So plus d, right? And there it is. Now, if you want, you can go ahead and clean up this first term. That way we're dealing with the coefficients out in front on all of our terms. So for example, you could say capital F of x is equal to 1 over 4, and then x to the 4th power, plus 1 over 6, x to the 3rd power, plus 1/2, x to the 2nd power, plus cx, and then plus d. All right, and there we go. So that was definitely a longer one. You actually had to take the antiderivative 2 times there. But hopefully that made sense. Again, follow your progression. You went from f prime of x to f of x, and then finally to capital F of x, which would be the antiderivative of the original f of x. Okay? All right, let's try one more quick example and we'll be done. Okay, so here's my next example. They give me the original f of x. They want me to simply find capital F of x, which is the antiderivative of f of x. So you're dealing with pi here. That's why I wanted to do this one, to show you how this one will work out. So I'm going to say capital F of x is going to be equal to the antiderivative of f of x dx, which is equal to the antiderivative of, let's go ahead and substitute it in, 4x squared plus pi and then dx. So capital F of x is equal to, applying our power rule, we're going to add 1 on our first term here and then divide by that number, which is going to be 3. So I'm going to write it as 4/3 and then x to the 3rd power, okay? And then we have plus pi x, because pi is a constant, right? So the same way you would go ahead and take the antiderivative of, let's say, like 5. You would say 5x here. Well, remember, pi is 3.14 and it just continues on and on and on. It's irrational. So we're going to go ahead and take the antiderivative of pi the same way we would a constant. And then again, in respect to x, so we say pi x. And then lastly, we have to include our constant of integration, so plus c, right? And there it is. So that is the antiderivative, and in particular using the power rule. It's pretty straightforward. Just remember that you include your constant of integration at the end. That's very important. And make sure you're following your rule of adding 1 on the exponent and then putting that number on the denominator, and you should get it correct. Okay, so that is it. I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.